So today we're going to learn about how to solve equations using absolute value, involving absolute value. Alright, so to solve this, absolute value is equal to 3. To do this, you have to use the definition of absolute value. Alright, so let's do this. So how does that work? So we want to solve this. Okay, so what you do is, so you click on this. Okay, alright. So to do this, let's use the definition of absolute value x. You may recall earlier absolute value of x equal to x if x is positive, and negative x if x is negative. So therefore, I will divide into two cases, into x equal to 3 or negative x equal to 3, because absolute value of x can be x or negative x. And then you solve for x, so x will now be 3, the other one will be negative 3. So you can do it this way. The other way to do it is you're going to consider the two numbers, absolute value of 3, which is 3, and absolute value of negative 3 is also 3. So in both cases, when you substitute 3 into this equation, I get 3. If I substitute negative 3 into that equation, I also get 3. That means x can be 3 or negative 3. Yeah. Okay, good. Alright, so we'll probably prefer method 2 because it's much shorter. Alright, let's try this again. So if absolute value of x equal to 3, it can be 3 or negative 3. So to do this one, you write x minus 4 equal to 3 or x minus 4 equal to negative 3. So therefore, x equal to 7 or x equal to negative 1. Alright? Okay, we'll do the next one. Same thing, 2x minus 3 can be positive 7 or 2x minus 3 is negative 7. And you solve for both. X can be 5. And the other one, 2x equal to negative 4. So therefore, x equal to negative 2. Right, we've done both of these questions. What do you have absolute values on both sides? So would that be more cases? Let's see how that works. You could have both positive, or both, or one negative, one positive, or one positive, one negative, or both negative. So that translates to 2x minus 1 equal to x plus 2. That translates to negative 2x minus 1 equal to x plus 2. And that translates to 2x minus 1 equal to negative x plus 2. And both negative, like that. Which means you have to solve 4 different equations. But that will not be the case because you will see 2 cases are actually identical. Okay, so you will see that if I multiply both sides by negative 1, that means the negative get cancelled, we get this case. So these two are the same. And same for these two, if I multiply both sides by negative 1, I get the other case. So really there are 2 cases. So these two are the same. So what do we do? Well, to do this, all you have to do is to do 2 cases. So let's put it back. Alright, so you will do the case 1 will be 2x, both are positive. And then, or the second case is 2x minus 1 equal to negative x plus 2. So if you subtract both sides by x, you get x minus 1 equal to 2, x equal to 3. For the other one, you expand negative x minus 2. So therefore, 3x minus 1 is negative 2. 3x equal to negative 1. And then x equal to negative a third. Alright. How about the next one? You do the same thing. X minus 1 equal to x plus 4. Or x minus 1 equal to negative x plus 4. And then you get x to cancel. You get this, isn't it? Which is no solution. And then the other one, you get x minus 1 equal to negative x minus 4. 2x minus 1 equal to negative 4. 2x equal to negative 3. X equal to negative 3 over 2. Alright, so you get two solutions or one solutions. Okay, done. Any questions? Make sure you show these working in your book. And there's other questions we have to do. Let's do this. Let's turn to the next page. What if you have an absolute value on one side, no absolute value on the other side? You just do two cases as well. But the only thing extra you have to do is to check the solution. Why do you have to check the solution? Because this side could be negative and this side is always positive. So then you get this inconsistency. So you have to check your answer. Okay, just remember, if you've got no absolute value on one side, you have to check the answer. But how come I didn't check the answer for this? These ones, well, because 3 is always positive, isn't it? And 7 is always positive. I don't need to check the answer, but I do need to check when it's a pronumeral with no absolute value. Alright, let's solve this. So you have two cases, 2 plus 3q equal to 2 plus 1. The other one is 2 plus 3q. Doesn't matter which side for negative, you get the same thing. So you get 2q equal to like this, and then 2q equals to negative 1, q is negative half. Or you can get 2 plus 3q equal to negative q minus 1, so you get 4q equal to negative 3, and then negative 3 divided by 4 is equal to that. Oh. Okay, so we've got these two solutions. And then we have to check both of them. How do we check it? We'll write down the original equation. 2 plus 3q equal to absolute value q plus 1, and then we check. So we check the first one, q equal to negative half. So you go left hand side is 2 plus 3 times negative half. Using a calculator, it should be half. And then on the right hand side, it's the same thing. Will also half. So therefore, that's a solution. And then you have to check the other one, negative 3 over 4. Right? So you go left hand side equal to 2 plus 3 times negative 3 over 4, which is negative 9 over 4. So you get negative a quarter. Negative a quarter. Okay. And then we're going to do the right hand side, which is equal to absolute value of negative 3 over 4. That will be a positive quarter. So they're not the same, isn't it? So therefore we have to eliminate this solution. So your final answer will be, therefore q equal to half only, or negative half. That's your only answer. So we have to reject the other one. Okay? And same thing for all the next three questions. So you could have one solution, you could have two solutions, you could have no solutions. So, alright, let's do that. So let's do the next one. So I think it's the same thing. It's the same question, isn't it? These two are the same. You can solve it again if you want to, but you don't need to. Or negative 2 plus 3q equal to negative bracket q plus 1. Alright. So 3q negative q plus 1. So you'll get the same thing. Q is half, negative half, or negative 3 over 4. But now you substitute into a different equation because now you're checking whether these one work for this equation. Alright, let's see if it works. So let's check this negative half first. So if you do negative half, that should work. So 2 plus negative half times 3, which will still get you half. The left hand side and the right hand side, you get negative half plus 1 is just half. So that works. So this one works. And then you check the other one. Q equal to minus 3 over 4, check. So the left hand side equal to 2 plus 3 times negative 3 over 4. And if you do that, that will be negative a quarter, but due to the absolute value, it becomes positive. On the other one, right-hand side is also positive. So it works. So in this case, both work. Therefore, Q equals to negative half, negative 3/4. Alright, good. Let's make this a bit larger. Look at that. And then finally, we got this question, which we get, so let's draw a line in the middle. So again, there are two cases. This one you get 2x plus 5 is x, or that's okay, or 2x plus 5 equals to negative x. So if you solve both of these, you get x equal to negative 5, or 3x equals to negative 5. X is negative 5, so you get x is negative 5 over 3. And you'll see that if I substitute onto the right hand side, you get negative 5 when x equals to negative 5. For the left hand side, you get positive, which is equal to, which is positive. So they don't match. I don't think it matches for this as well. So therefore, and also you can check this one, right hand side is negative 5 over 3, and then if you do the left hand side, you should get exactly the same thing, except it is positive 5 over 3. So not a solution, so therefore no solution. Right, done. Okay, so it's the absolute value equations. And then the last thing we'll do today is inequality. Alright, there's a harder question. If we have time, we'll do it. Otherwise, we'll leave it next time. Okay. This one's not very important. I don't think they asked that in unit, but it's good to know. Alright, let's look at this one. Inequalities. So how do we solve inequalities? As the value of x less than 2 means the distance from the origin is equal or less than 2. So what are the numbers that are less than 2 units away from the origin? Everything here, isn't it? Right? All these number works, so x is 2, 1, negative 1, negative 2, and of course odd numbers in between like 1.5, etc. So we see that if the answer to this inequality will just be x between 2 or negative 2. If it's bigger than 2, then all the numbers has to be here, or all the numbers here, isn't it? Because 2 is bigger than 2, absolute value 3 is more than 2, and so is the negative numbers. They have an absolute value, or the distance from the origin being more than 2. So when you see a bigger than, you write x less than negative 2, or x is more than 2. So x less than negative 2, this bit, x more than 2, this bit. Yeah. So now we have a conclusion. So whenever you see this equation of the form x less than a, in between, bigger than, it's bigger than or less than. So I wrote above, same for the less than or equal to. So we're going to solve this inequality. Remember this formula is not on the formula sheet. So when it's a less than, you write x minus 4 in the middle, in between the positive and the negative, like we did there. Right? Between 2 and negative 2, when it's like this. Okay? And then you just have to add 4 to both sides, and you get 1 less than x less than 7. Alright, how about the next one? If it's bigger than, you do 7 minus 2x bigger than 9, or 7 minus 2x less than negative 9. So two cases. So negative 2x bigger than 2, x is less than or equal to, divided by negative is reversing the sign. Negative 2x less than or equal to negative 16, x is bigger than or equal to 8. And then you have to grab the solution on the number line. I forgot to do that. So you draw this, x, this is 8, this is negative 1, that side or of this side. Okay? And the same thing goes for this one, in between 7 and 1. Alright, that's the graphing the solution on the number line. Right, any questions? So hopefully it's all pretty clear to you. Yeah, alright, we'll just do, there's 2 more. Yeah, let's finish these. So it's all done. Okay, so we've got bigger than, so remember bigger than, you do 2, 7 or less than -7. So 3x bigger than 8, so x is bigger than 8 over 3, or 3x less than -6, x less than -2. So you could go like this, -2 less than, or 8 over 3 more than, right? That's all you have to do when you draw the graph on the number line. Now this one, due to the fact less than, it's in between the 5 and the -5, so you add -3 on both, so you get, hello, yeah, hi, yeah, yep, alright, and then you do -8, -2x, 2 divided by -2, when you divide by -2, you get 4, but less bigger than x bigger than -1. And when you see this, make sure you go around, put the negative there, or reverse the inequality. Yeah. And then you can graph it, which is between -1 and 4. Circle like this. X. Alright, done. Right, so it's all done over here. Okay, good. So stop the video.